Let's look at the different components available in this laboratory, which will be helpful for us in conducting the experiments listed in the syllabus. So let's look at the different components. First is a resistor. Now all of you are aware of the color code. B.B. Roy of Great Britain had a very good wife. So based on that, if you try to read the resistance value, this is basically a ceramic resistor, which is a quarter watt resistor. So the maximum power which this can withstand is only quarter watt. So if you read the color code, you have red, and finally you have a golden last ring. So the resistance of this is 2.2 kilo ohms. So one should be aware of this color coding. Only then we'll be able to read the resistance value. So to have one more example, let's look at the second resistance. Now if you see the color code of this, you have a brown, black, orange and a golden ring. So this resistance value is 10 kilo ohm. So likewise you can measure the resistance value. So there is one more kind of resistance which is called as a wire wound resistor, and this has a better power capacity. So the value is also written on this. The power value is 5 watt. So this is basically a 500 ohm resistor with a power value of 5 watts. So this can withstand a power of up till 5 watts. So when we are dealing with half wave and full wave rectifiers, or when we are dealing with the actual power 230 volts, in such cases we are supposed to use this kind of resistor. For all other simple experiments, we are going to use this kind of ceramic resistor. So one should be aware of this. So whenever we are dealing with the transformers and high voltage, we are going for wire wound. When we are dealing with simple experiments like clippers and clampers, we are going to use this kind of ceramic resistor. Next component is a potentiometer. So whenever we want a variable resistance value, so all these resistors will give fixed value, but if I want to change the resistance value quite often, we are going to use one more kind of resistance, which is basically a potentiometer. So this is basically a 1 kilo ohm potentiometer. So if you vary this, the resistance varies from 0 till 1 kilo ohm. So likewise we have two different ratings. One is 1K, other one is 10 kilo ohm potentiometer. Next is a capacitor. Now you can see two different types of capacitors here. I am holding it. So this is a ceramic capacitor. This is an electrolytic capacitor. The difference between these two is, whenever we want small capacitance values, we go for ceramic capacitor. Whenever I want high capacitance value, I go for electrolytic capacitor. Ceramic capacitors basically don't have polarity, so you can connect it in any way you want it. But when it comes to electrolytic capacitors, there will always be a polarity. The longer lead is positive, the shorter lead is negative. And if you try to read the capacitance value of this is basically a 1000 microfarad capacitor. But the capacitance value of this is 0.001 microfarad capacitance. So that is how we get to know the difference between these two capacitors. Next is the inductor. So if I want to have a very small inductance value, there is a fixed inductor available in the laboratory. So this is basically 1 millihenry inductor, and the same color code is applicable even for this, which is as good as the resistor color code. Then comes the family of diodes. So all of us are aware of what is basically a diode. A diode is basically a two-terminal semiconductor device which has the anode and cathode terminal. So how do you basically identify this diode? So the silver ring, wherever the silver ring is there, that side is basically cathode, the other side is anode. So in this case, this is anode and this is cathode, and there is a silver ring here. Towards that, the cathode will be there. So one should be aware of this. You should always look at the silver ring and then identify the anode and cathode. This is also one more type of diode. The numbers will change, the ratings will change, but all of them are basically diodes. They all operate or perform in the same way. So if you see this particular diode, how do you identify this? There is no ring as such, but the flatter part indicates the anode, the pointed or the blunt part indicates the cathode. So this is anode terminal, this is cathode terminal. The next type of diode is this. You can see a black ring here. Let me hold it this way. The black ring indicates the cathode part, the other side indicates the anode. So this is a Zener diode. So as we have one more experiment relevant to Zeners, we have to understand, or we need to get to know how basically the identification of anode and cathode is done. So the black ring is the cathode, the other side is the anode. So this Zener diode always works in the reverse bias condition, if at all, we have to use it as a regulator. And there is one more kind of diode which all of us are familiar with. This is basically a light emitting diode. So the longer lead and shorter lead indicates anode and cathode in this case. Next is a family of, I can just have a look into the different components that we discussed. First is resistor, different types of resistors, including the potentiometer. Next is the capacitors, different types. Then you have this one single set of inductor, which is 1 millihenry fixed, available in the laboratory. Then you have the family of diodes, LED, normal diode, as well as the Zener diode. Now we'll get into a slightly higher level of components as such, which is a transistor. So we have a lot of applications relevant to this transistor. So the number of this is CL100. So this is basically a NPN transistor. Now all of us know a transistor will have 3 leads, emitter, base and collector. Now how do you identify the terminals of a transistor? So if you hold it this way, where these leads are pointing upward, there is a notch present here. So you start reading it from the notch. You will have emitter, base and collector. So let me repeat it. From the notch, you start reading this as emitter, base and collector, E, B and C. Next is one more kind of resistor, which is a power resistor. So just to make you people familiar of this, families of transistor, we are showing this. Otherwise, we are not going to use this as such in this laboratory. So this is basically a power transistor. So one more family of transistor is JFET, junction field effect transistor. So if you know already what is JFET, JFET will have 3 terminals, in fact 4, where the gate is internally connected. So as such, a JFET will have 4 terminals, but one is redundant. So how do you basically start reading it? You start reading it again from the notch, hold it in such a way that the leads are facing upward, start from the notch, source, drain and gate. So the 4th one is again a gate terminal. So you don't have to worry about this. Okay. So this is how you read the JFET. Next, we have one more family of FET, which is metal oxide field effect transistor. So again, this contains source, gate and drain. You will get to know once we start, doing the experiment, how we can use this and what is source, which is drain and which is gate. So this is again one more family of transistor, JFET. Now what you can observe here, what you can see here is basically a silicon controlled rectifier. Okay, so we are going to use this as well. We are going to use this as well in our experiment. A silicon controlled rectifier will have again 3 terminals. One of the terminal is anode, the second terminal is cathode, and the third terminal will be the gate terminal. So once we get into the experiment, we will understand how to use the silicon controlled rectifier. So apart from this, we have few more special kind of components available in the laboratory, which we are going to use in conducting few experiments relevant to the characteristics of LDR, relevant to the characteristics of phototransistors and all those things. So what we see here is basically a light dependent resistor, wherein whenever the light falls on this, the resistance is either going to increase or reduce. That is what we need to find. So we need to find the characteristic feature of this particular LDR, how basically the resistance varies when the light falls on it, or when the intensity of light changes, what is going to happen to this resistor. So we are going to understand this, and we'll also be doing a application kind of experiment in this particular laboratory. So this is basically a thermistor. So what basically is a thermistor? As and when the temperature changes, the resistance of it is going to vary. Again, we need to find whether the resistance increases or decreases when the temperature changes. So this is one more experiment. And what we have here is a phototransistor. So this is basically a phototransistor. We are going to use this as well in our experiment. And next is a breadboard. You have a multimeter, you have a galvanometer, you have a transformer, you have a springboard. There are 3 boxes here, which is decade capacitance box, decade inductance box and decade resistance box. So just to give you a feel of what basically these decay boxes are, I'll just take up this, let's say a resistance box. Let me take up a decay resistance box and tell you how we can use this. So if you can observe, there are too many dials here, and below every dial you can see the values written: 1 ohms, 10 ohms, 100 ohms, 1 kilo ohm, 10 kilo ohm, 100 kilo ohm. So let's say now initially all these are pointed towards 0. So it means the resistance coming out of this, or the resistance offered by this box right now is 0 ohms. Let us say I want to put the resistance value as 125 kilo ohms. Just for example, 125 kilo ohms. So 125 kilo ohms involves 100 kilo ohms, 20 kilo ohms, 5 kilo ohms, and all other dials are at 0. So when you read it, you have 100k plus 20k plus 5k. So in total you get 125 kilo ohms. Now where do you connect the wire to get that much of resistance? We can see 3 notches here. We always, in this laboratory, we are always concentrating only on the black as well as the red one. So connect one wire to this, the other wire to this, and we all know that resistors don't have any polarities. So you can connect it